Let W1 be the real vector space of all 5 by 2 matrices such that the sum of the entries in each row is 0, and W2 with the real vector space of all 5 by 2 matrices such that sum of the entries in each column is 0, then the dimension of the intersection of these two. As we know that W1 is 5 by 2 contains 5 by 2 matrices, and structure of this matrix you can see as this is W1. So in W1 elements are like this. Suppose it is A, B, C, D, E, F, G, H, I, J. This is 5 by 2 cross matrices, and the property on the elements or the elements of the row are sum of each row is 0, then C plus D equal to 0, and same as for other rows. So from first equation you can write A equal to minus B or B equal to minus A. So this matrix can be written as A minus A, B minus B. If this element is B, then minus B. If this is C, minus C, D minus D, and E minus E. And the size of this matrix is again 5 by 2. And here you can understand, if we know the value of A, then this entry is negative of that one. And similarly for other, that means that we have only these A, B, C, D, and E independent choices to select. So dimension of W1 is equal to 5. Now come to the W2. W2 is same 5 by 2 matrices A, B, C, D, E, F, G, H, and I, J. So this is again 5 by 2 matrices, and the property is that column sum is 0. To make column sum is 0, so A plus C plus E plus G plus I equal to 0. From this one I can write I equal to negative of minus of A plus C plus E plus G plus I. So this element can I can write this element I can write negative of A plus C plus E plus G plus I, or in other words you can say some negative of sum of other four top elements. Similarly, this entry will be negative of B plus D plus F plus H. So dimension of this vector space W2 is equal to 8, because of the circular part entries will contribute in dimension, and these are independent choices. So dimension of W2 is 8, and we need to find dimension of intersection, means dimension of W1 intersection W2. Recall one point, as the dimension of W1 is 5 and dimension of W2 is 8. So dimension of intersection W1 intersection W2 must be less than equal to mean value of 5 comma 8. It means that dimension of intersection at most 5. So we will verify this using this problem, and you can see in few minutes. So suppose a matrix size of 5 cross 2 is belonging to W1 intersection W2. It means that this matrix is satisfying the property of W1 as well as property of W2. If this matrix is satisfying property of W1, that means that I can write element row wise A minus A, B minus B, C minus C, D minus D, E minus E, and the last row I think this is 5 by 2 matrices 1 2 3 4 5. It's okay. And this entry must be negative of sum of other fours a plus b plus c plus d, and this entry is same as a plus b plus c plus d to make property of W2. So what we have? We have only A, B, C and D are independent choices. So we have only 4 independent choices. So dimension of intersection is 4. Because of these 4 entries only contributing in spanning. So W1 intersection W2 is equal to 4. So you can see here dimension of intersection is 4 and 4 is less than equal to 5. So this property is also hold. So answer of this problem is 4.